today's episode of Future Says, we have Anne Pauley, Technical Program Manager at Google. Welcome to the show, Anne.
Thank you. I'm glad to be here.
Tell us a bit more about yourself and your role at Google.
Yeah, so my background is mechanical engineering, and I work in manufacturing operations at Google. So in the past, I've been in all kinds of different roles. I've worked at private company, a startup, a couple big companies, like gone all over the place. And in all of those roles, I was in some kind of design or engineering or manufacturing role. And so I've kind of built up this skill set that includes a lot of design work, but also a lot of that kind of on the ground manufacturing work. And so what I do now at Google is I work on some of our Pixel products and try to figure out how we can optimize them for manufacturing. So how can we build things more efficiently? How can we find all of the potential risks that we'd see in manufacturing as early as possible so we can fix them?
Okay, so tell us about Google's Pixel products. What do they look like? How are they engineered? How are they designed? How are they manufactured?
So the Pixel line right now is phones, earbuds, and watch. And so the phone, which I inconveniently put over there, is we're kind of our claim to fame is having best in industry cameras. So we really build the phone around the cameras, and they're front and center on the phones. But overall, the design of the Pixel line is just really nice, really modern, really sleek. Really like simple and clean.
Interesting. And what innovative approaches goes into the design and engineering of a Pixel phone?
They're really design oriented. So even on the manufacturing side, a lot of times we're going back to that design intent and making sure that we keep really close to exactly what we want the design language to be, and all those teeny tiny details that make a really nice looking and a nice feeling product. So extremely design focused.
Okay, and I know you have a big background in 3D printing as well. Is that something that goes into the engineering of a Pixel phone?
Yeah, so 3D printing is kind of behind the scenes whenever you're building hardware products. So most products don't have 3D printing in the final design, but we use a ton of 3D printing in the process. So we prototype the actual parts a lot. We do iterative prototyping, iterative assembly testing, to make sure that not only the parts fit together, but try to find any of those little things that we can improve on them.
Okay, and how long have you been doing 3D printing? How many years?
Oh, so I started 3D printing in college.
Okay.
So 3D printing has kind of an interesting history to it. It's got some really big distinct phases. So around the 80s, a lot of these
It existed in the 80s? 3D printing? Okay.
Yeah, see, a lot of people don't realize that. So a lot of these processes, the 3D printing processes, were developed in the 80s. So some of the main ones are SLA printing, which is where you have photo-cured resin that you're curing in layers. SLS printing, which uses a powder bed. So usually nylon is the most common material. It's kind of a bed of really fine plastic, and it's being cured with a laser. And FDM printing or FFF printing, which is what you see most often, which is where you have plastic that's basically being melted, extruded, and then it solidifies again. So all of those processes were developed in the 80s, but because they were developed in the 80s, they were patented in the 80s. And so for a long time, it was kind of a closed ecosystem of who could sell 3D printers. So around 2005 to 2008 or so, those patents started expiring. And so that's why a lot of people think that 3D printing is fairly new, because as soon as all of those patents expired, everything exploded. And so you got the open source 3D printing movement, and you had lots and lots of companies just coming out of the woodwork to build their own versions.
And what year was that around that all the patents expired?
About 2005 to 2008.
Okay, so let's say 15 years ago, 15 to 20 years ago.
Mm-hmm.
That's so interesting. So what's happened then in the 15 to 20 years since those patents expired and all of a sudden it's an innovation open for everybody?
Yeah, so basically when the patent expired, the biggest thing that happened is the open source 3D printing movement. So there was a program called RepRap that the entire concept was that you could build a machine that you could that could make the parts to build another one of itself. And that's why it was called RepRap. And so this whole movement, loose organization of nerds, was developing and improving these open source 3D printer designs, and this is about the time where I came into it.
Yep.
So when I went to college and found out about 3D printing, there weren't many affordable 3D printers that you could go out and buy. We were kind of stick building them out of parts. Like we were using existing printers to build the custom parts that we needed, and then everything else was like rods that we bought or tubing that we bought, and just parts that you could go out to the hardware store and buy.
Okay. And if you take now we're in 2024, what is easy to 3D print and what's hard to 3D print?
It's a lot easier now. Okay. So if you go to any show or any like 3D printing store or anything like that, you can just go and buy a printer and take it home and it's ready to go for a pretty affordable price, like less than $1,000, even a couple hundred for some of them. And it just super lowers the barrier to entry for 3D printing. So basically anybody can take home mostly FDM or FFF, which is the plastic filament that's being melted in a nozzle, that type of printer. Those ones are super affordable and super accessible. And so the biggest limits to what you can print are the materials and the process. So those are the two things you have to think about. So you can't easily print with any material. If you're using a printer that uses melted plastic or thermoplastic, then you have to pick one of those materials. And the process, you're kind of limited. You just like imagine creating something with a hot glue gun. It's basically a much more fine-tuned, advanced version of that. You can't just make things in thin air using that technology. You have to design knowing that you'll have some things like heat warpage or needing to support parts so that you're not just printing on air. There's kind of a lot of considerations that are all tied to the process that you have to think about.
It's incredible. On another episode of this podcast, we had Jonathan from Redefined Meat talking about 3D printed foods, which for me is mind-boggling. What are some of the craziest things you've seen in your career that have been 3D printed?
Ooh, I think the 3D printed meat's pretty wild.
Yeah.
Bioprinting is a thing that I personally don't know much about, but it's really cool. Kind of one of the coolest things about that to me is that you have that issue where you can't print on air. There's a lot of interesting bioprinting that's happening where they're printing within a fluid or within a gel or something like that in order to make all these complicated things like meats or just other biological designs.
Yeah. So if you're saying 3D printing has been around for roughly 40 years, it's been open sourced for roughly 20 years. Mm-hmm. What do you think the next 20 to 40 years, how much better could it get? What direction is that heading?
So we're definitely getting bigger and smaller. So to get smaller than what we can already make, it gets just infinitely more difficult. So you're getting down to using piezoelectronics to create really, really tiny, really, really accurate things. And then if you want to build big, like buildings or boats or just anything that's room size or bigger, then it's really more of a structural engineering challenge.
Yeah.
So you're building bigger and building smaller are the two most difficult things.
You think you could build a boat? 3D print a boat?
Yeah, people are doing it.
3D printing boats?
Yeah.
It's unbelievable. Wow. Must be big printers.
Mm-hmm.
Oh my gosh.
Yeah, very big.
Does this go hand in hand with DFM and design for manufacturability? Is that around 3D printing? Can you talk a bit more about that?
Yeah, so DFM is extremely broad. So there's part design, there's designing for assembly, and just kind of overall how do you make a thing. So if you're looking at part design, that kind of comes down to what I mentioned with thinking about materials and thinking about process. So you can look at all the materials that you have available, and you can look at all the processes that you have available, and then the part that you want to make, and figure out what combination of them will get you to where you're at. And so, like, if you're in consumer electronics, we're doing a lot of injection molding parts, and that checks a lot of boxes because it's a really versatile material, and we can make these really small detailed parts. They're durable, they're safe, and we can manufacture them efficiently. But like say I'm building a car part, probably not that process. Like I'm probably doing something like casting metals or machining metals. And that's just totally different set of materials and processes. So that's kind of making your part, and then the thing that's kind of more the thing that I find most interesting is designing for assembly and kind of designing that entire part. So more holistic look at the design, because then you get into all this really interesting, and in my opinion, kind of more creative design, where you're trying to figure out what's the best way to assemble these parts together. So you can assemble things so many different ways. You can glue them, you can screw them together, you can snap them together, and like a whole list of things. Like what's the best way to do this, and what's the most efficient way to do this? And then you get a lot of interesting challenges with like consistency of your parts. So when you're making millions of things, it's a whole different ball game than when you're making a dozen of something or 100 of something or even 1,000 of something. You have to have every single little part of your design nailed down. Like your parts have to be perfect, your assembly process has to be perfect, and then you're trying to optimize that entire thing.
Sure. And a lot of that design, if not all of that design, is done in simulation virtual environments. Is that right?
Mm-hmm. Yeah, so that's actually where 3D printing comes in. The design work is all happening on a computer, but in order to actually get parts in our hands without scaling it up to full production, which is just not feasible.
Yeah.
It's time intensive, it's cost intensive. Like 3D printing is perfect for testing everything out ahead of time. So I'm a huge advocate for just printing everything. every single time we make a change to make sure that we're sanity checking the design, because when you're looking at it on the computer, it's really easy to miss a lot of details, or just miss things like the feel of it, or the force it takes to assemble stuff together, or testing out different processes. Like when you're using machines to assemble things together, you have to test out every single one of those steps before you actually go to make the thing.
Sure. So you're making a phone, you've done the design, which is a holistic design, and then for each individual part, you're 3D printing that, taking it out and you're testing it, and then you're making iterations, and then you're creating an actual physical, non-3D printed to input. Is there any particularly difficult elements of the phone to design or to print?
Oh man, I actually have been done more work on the earbuds and the earbuds cases.
Okay, tell us more about
side
that.
of
Yeah.
things. So that I think 3D printing is hugely effective for, because all of the parts in those products, a lot of them are injection molded. They're very complicated. They have a lot of complicated what's called tolerance stack up, which is, do all your part dimensions stack up and fit together, and you have a certain margin of error in every single dimension that you have within a stack up. And if they add up the wrong way, then your parts don't fit together right. And so, like, 3D printing is amazing for trying to find all those little errors or difficulties in assembling it. Like, even before I was doing this job, I did a lot of design engineer work for a lot of different products. I worked in consulting for a couple years, so I worked with a lot of startups and a lot of just really odd products. And I really learned to not trust myself. Like, even if something looked good on the computer, a lot of times, pretty much every single time that I printed it out and tried to assemble it together, I would find something that I messed up. Like, some little piece is sticking out, and then you can't push things down from the top, or the snap together just isn't right, or just something goes wrong. And the more you're able to test things out as soon as possible, the faster you can move forward and not make mistakes, not have unfixable mistakes later in the process.
Yeah. Very interesting. And I guess all of this is trying to improve the quality and reduce scraps, which again ties into sustainability and being better for the environment. I know you're quite passionate about that as well, and you talked to us about how corporations are prioritizing environmental sustainability at the moment.
Yeah, so I definitely care a lot about that. It's a really complicated problem to tackle because so many things go into it. I think one of the biggest things that we have to tackle is the materials side of things. So as mechanical engineers, we're kind of stuck with whatever the material scientists are able to manufacture for us. And if those materials are not sustainable, but we can't make our parts any other way, then we're kind of stuck with what we've got. So that's basically where we're at with a lot of consumer products right now. A lot of the more sustainable products, like the bio-based plastics and the just plastics from different sources besides petroleum, or all the different additives in polymers, they're just not at the quality that we need to make parts and make things that people are using for years on end. Like we need materials that won't degrade within the lifetime of the product, because it's not a sustainable product if it breaks down before somebody was done using it. If you scrap it, then you're not really benefiting anyone.
Sure. So how would you change that process then? If you were in charge, how would you improve the sustainability of those processes?
I mean, if I was in charge of, man, I'm not a materials scientist, so I don't even know where to start with that.
Yeah.
I just kind of have to hope that we're getting closer to where we have to be with the material properties, that we need to start replacing some of these petroleum plastics.
Sure.
But there's a lot more things that go into it as well. The way that we design things in order to be able to disassemble them and recycle the parts that are within it also goes into how sustainable something is. So, for example, on a phone, there's a lot of aluminum in there. So can we disassemble a part and reclaim that material? And, for example, if one part of the phone, like if the battery needs to be replaced but the rest of it's fine, we have to design around that and be able to replace those parts to extend the lifetime.
Yeah. I know I worked with a company recently that wanted to move away from plastic packaging, and they were trying to test lots of different materials, and they had decided that algae and sort of mushroom-based packaging was the best way forward. Have you seen any interesting new materials within your work?
Yeah, I've seen mycelium packaging.
Okay.
I haven't bought any products yet that have come in mycelium packaging, but I definitely hope that I'll get something and it'll have mycelium packaging. I'll be very excited.
Yeah.
But our company and a lot of other companies are doing 100% non-plastic packaging. So I think that's becoming more and more common and more of a standard.
Okay. And then it's the year 2024, so I have to ask you about AI. Is it impacting your work? Is it separate to what you're doing? Are you passionate about it? Where do you think it's all going?
Man, I'm also not my area of expertise. Yeah. But AI comes in a lot of different forms. It's kind of hard to say. It's kind of hard to pinpoint exactly what it entails. So in my mind, the way that AI ties into the kind of stuff that I do is where we're getting more and more smart in how we manufacture things, like using computer vision to inspect things in a more automated way. So find errors with computer vision, which you could call AI, instead of having to have a person look at every single thing and inspect it. And hopefully using that technique is not only saves some poor person for having to look at a ton of different things with a microscope, but it is more efficient and hopefully more accurate.
Okay, interesting. Another thing that I know you get very involved in, Anne, is around mentorship. Mm-hmm. Can you talk about some of the different mentorship programs you're involved in?
Yeah, so I really like trying to reach out to especially communities of women that are working in tech and 3D printing. So I do a lot of work with an organization called Women in 3D Printing. I lead the San Francisco chapter of the organization, and we're just a very chill group of people that just want to create more visibility for women working in the industry. because as in many types of tech, it's getting much better, but we're still a small percentage of the workforce. And so we do a lot of events that are open to anybody, that just like give women the opportunity to speak, give women the opportunity to showcase their work in a space that they know that they will be welcomed, and celebrated.
Sure. So what sort of events do you do?
So the organization as a whole does a national conference every year. So I actually got to be a keynote speaker for it this last year, or beginning of 2023, yeah, which was very exciting. And then we do more local events. So there are, not exactly sure how many, I think somewhere around 150 or so chapters across the world, including the US, Asia, Europe, Australia, just all over the world and on all the continents. And we just create low pressure opportunities for people to come and meet each other and build those connections in the community. And we get a really, really diverse group of people coming in. So we get a lot of men in the industry as well that join our events because they want to be part of the community as well and support what we're doing.
Amazing. And you must have people coming from so many different industries using the same technology but for various different use cases. Is that right?
Yeah, really, really diverse use cases. So there are plenty of people like me who work in product development, but we have a lot of people that work in aerospace doing things like printing titanium, and people working in medical and people working in automotive. It's really all over the place.
Yeah. And so you said, in terms of the industry of 3D printing, we're definitely not there in terms of a diverse workforce. What should companies be doing to ensure that they have a more diverse workforce, that they're inspiring the females in their company to do more?
Yeah, I think the baseline is just having a good system for dealing with any cases of discrimination that come up, because it's more common than people think it is. So having that really robust system is important, not just for women, but anybody that experiences issues, and for kind of promoting women and other underrepresented groups. I think it's really important, and I really advocate for companies to encourage building those communities. So support ERGs, employee resource groups, to host events and just build those connections. Because even if you work in an industry that's less than 10% women, which it is still many industries, if you're able to help those women or other underrepresented groups connect with each other, that goes a long way to helping people feel like they're part of the community and feel welcome.
Brilliant. And we'll definitely include links in the show notes to some of the upcoming events in Women in 3D Printing. Final question. Let's end on a really positive note. What's the thing that excites you most about the future of product design?
I think I'm seeing more and more sustainable materials at CES, especially. So that's kind of to me a little bit of a marker on what people are bringing to a big show like this. And this is 2024 is my third year coming to the show, and so I'm definitely seeing much more of a focus on sustainable materials, and actually seeing some products that are centered around being made using sustainable materials, like some kind of more basic electronics like chargers and some different companies showcasing different material options.
So a greener future?
I hope so.
Enough's being done?
Never enough.
Never enough. Anne Pauley, thank you so much. Appreciate you joining the show.
Yeah, thank you so much.